M.Tech Biomedical Engineering, SRM University. The role of this work is to address obesity and low bone mass problems. We know that BMI, body mass index, is used as a common tool for obesity analysis, but the accuracy of it is questionable because BMI is a measure of body height and weight rather than the body fat. Hence, body fat is important to be determined to assess obesity. World Health Organization (WHO) has established a criteria in terms of BMI to assess obesity, but many researchers have found that this criteria differs with ethnicity. Also, that Asians have a lower BMI but higher fat. In that case, individuals who have higher percentage of fat and at high risk of obesity will be considered as normal when classified using BMI-based criteria. So, the Indian standards of BMI were given as BMI of 18.5 to 23 are considered as normal or healthy adults. BMI of 23 to 25 are considered to be at risk of obesity or can be classified as overweight, and BMI of greater than 25 are considered to be obese. The next part of his work is to address low bone mass. Osteoporosis is a disease that refers to thinning of bone, and it has become prevalent in India in the past decade. Thinning of bone refers to loss of the mineral density in the bone, and this leads to fragility and easy fractures. The risk factors of it generally include being a female gender, having a history of osteoporosis in the family, and having the habit of smoking or consuming alcohol. The golden standard of determining bone mineral density is the use of DEXA or a dual energy X-ray absorptiometry, but this is costly and so not widely available in India. Hence, a portable version of it called PDEXA, peripheral dual energy X-ray absorptiometry, is used to assess the bone mineral density at forearm and at calcaneus. Researchers and studies have found that the bone mineral density at forearm is associated with the density at the axial sites like hip and femur. Also, studies suggest that the grip strength of the hand may be influential on the bone mineral density. The grip strength of the hand can be determined by using a dynamometer. This instrument measures the hand grip strength in kilograms or pounds. This study aims at determining the correlation between hand grip strength and bone mineral density and assess the relationship between them and assess whether it can be used as a screening tool for osteoporosis. Each subject was asked to fill a health history questionnaire, and each one gave an informed consent for this study. The height of each subject was measured using a stadiometer, and the subject was asked to stand with barefoot. 174. This is peripheral dual energy X-ray absorptiometry (PDEXA). It's an osteosysmic and its modulus EXA 3000. This is used to measure the bone mineral density at forearm and calcaneus. The source of this machine is the stationary anode X-ray tube, and the detector is a charge coupled device. And every day before acquisition, the phantom is used to calibrate the machine. The phantom is provided by the manufacturer. The subject is asked to sit like this and then place his forearm inside this cavity towards the detector, and the subject is asked to close his fist. And then in the software which is given by the manufacturer, we have to choose the right location, in this case which is right forearm, and then the measurement is started. It takes approximately 5 to 10 seconds for each arm. Before that, the details of the subject has to be entered in the software. The name, age, sex and the ethnicity has to be entered, and this is the result. Here the bone mineral density is specified and the corresponding T-score is given. This is the image of the forearm bone. This person seems to have at the risk of, he has osteopenic condition since the T-score is very less. And the point is shown here in the yellow region, which shows it is osteopenic region. And further than this, it goes into the osteoporotic state. This is Standard NC980 MB body composition analyzer. This is multi-frequency analyzer. This is used to measure the body composition of the subjects. The subject is asked to stand with his bare feet on the electrodes, and then we have to enter the details of the subject and then give the start measurement. Subject is made to stand such that his feet touches all the foot electrodes. And then the weight of the subject is displayed. This weight is taken to eliminate the weight of the cloths. 0.8 kg has been fixed, and then the subject holds the electrodes and stands in a normal position like this with his arms hung down, and this takes approximately 30 seconds to analyze the composition of his body. And this machine also gives the composition which is present in each body segment like arm, leg and trunk. Retest the gloves. The result of this analysis is generated, and then this report gives the weight, fat, muscle mass, total body water, BMI and free fat mass of the subject, and also it gives the segmental analysis, like it displays the composition or fat distribution and muscle mass distribution in trunk, left and right arm, left and right legs. Also it gives the basal metabolic rate values, visceral fat rating. Visceral fat is the fat that is present in the abdomen, around the abdomen organs, and the total body water is displayed. Also it includes the extracellular water and intracellular water. This is able to be done because a very small amount of current like 90 microamps is being sent through the body of the subject at various frequencies like 1 kHz, 5 kHz, 50 kHz, 250 kHz, 500 kHz and 1000 kHz, and hence this is known as multi-frequency analyzer. It also gives the physique rating of the subject, whether the subject is fat, obese or solidly built. And it also provides an option for printing the results. This is baseline Smedley digital dynamometer. This is used to measure the hand grip strength. The subject is asked to sit like this with his shoulder adducted and wrist and forearm at 90 degrees with his wrist at between 0 and 30 degrees. This can measure the hand grip strength in both kgs and pounds. The subject is asked to hold it like this and pull it with maximum force, and this is done for 3 trials, and the mean of all these 3 trials are taken as the average one and used for calculations.
After acquiring this data, the analysis was done using SPSS software. For the obesity analysis, the Pearson correlation between various measured variables and body fat percentage was carried out, and the relationship between BMI and body fat percentage was determined by using the scatter plot. Using this equation, the body fat percentage cutoffs corresponding to WHO based BMI cutoffs were calculated, and using these cutoffs, the subjects were classified as healthy or overweight or obese. 33.3% of the studied population were found to be healthy, 15.6% were in the overweight category, and 51.1% fell into obese category. Stepwise multiple linear regression was performed with body fat percentage as dependent variable. When only regional body composition parameters were alone used, the R-square value was 0.95. When bioimpedance variables were only used, R-square value was 0.61. When anthropometric body circumferences were alone used as predictors, the R-square value was 0.86. The R-square value was highest of about 0.97 when a combination of regional body composition parameters and bioimpedance parameters were used. Using this model, an equation was framed to predict body fat percentage. The accuracy of this predicted model was checked by performing paired t-test with the actual body fat percentage values. The paired samples difference between them was not significant, with significance being 0.978. A scatter plot between the predicted and observed body fat percentage values was plotted to show their association. Also, an attempt was made to check if only anthropometric body circumferences can be used as a simple tool to assess body fat percentage, and hence the model obtained for the anthropometric parameters was chosen and the body fat percentage was predicted using that equation. The accuracy of it was assessed by performing a paired t-test, and again the paired samples difference between the predicted body fat percentage values and the observed values was not significant, and hence this model can be used efficiently to predict body fat percentage when only anthropometric measurements are available. An ROC analysis was carried out to examine the ability of the predicted body fat percentage from the best model to distinguish obesity and non-obesity. Sensitivity and specificity of about 95.7% and 97.7% respectively corresponded to the cutoff values of 35.5% of predicted body fat, which was determined from the coordinates of the ROC curve. This implied that the predicted body fat percentage value would classify a subject as obese 95.7% of the time, and when the subject is truly obese, but will misclassify them as obese 4.3% of the time. The area under curve value was 0.97. The agreement between classification by the body fat percentage criteria from the ROC curve and the BMI criteria for categorizing obese and non-obese subjects was carried out using kappa statistic and was resulted in a fair agreement with kappa is equal to 0.33. Hence, this method can be used as a screening tool for predicting body fat percentage and hence to evaluate obesity. The next part of this work is the low bone mass analysis, aiming at finding a simpler method to predict bone mineral density in order to assess evaluation of osteoporosis. The correlation between average forearm BMD bone mineral density value and the various other parameters were analyzed. The age was significantly but negatively correlated with BMD. The hand grip strength was found to be positively associated with forearm BMD in a significant way. Their relationship is represented in the scatter plot. Stepwise multiple linear regression models were framed for the prediction of forearm BMD, and the best model based on the R-square value was chosen. The model used leg muscle mass, height and hand grip strength parameters to predict forearm BMD. Based on the WHO classification, a T-score of more than -1 was considered to be normal and less than -1 was considered to be low bone mass category. This criteria can be applied to the standard method of BMD measurement only, and hence the femur neck BMD was calculated from the forearm BMD by using the machine specific equation 0.706 into forearm BMD measured by EXR 3000 minus 0.440. This equation was suggested by Marwaha et al. The T-score was calculated by using the formula measured value minus sex-matched young adult mean divided by sex-matched young adult standard deviation. This table shows the number of the studied subjects who fell into normal and low bone mass groups considering the measured or actual BMD value and the predicted value from the equation. A feed-forward backpropagation network with scaled conjugate gradient algorithm was used to evaluate low bone mass using the measured variables. A set of female samples was held back to be used to test the system after it had undergone its training to avoid memorization in some non-significant way. Hence, 60 samples of female data were used for training the network and 30 were used to test the same. A total of 73 input features such as anthropometric measurements including body circumferences, total and regional body composition parameters, and segmental bioimpedance variables were used to evaluate low bone mass. One hidden layer was selected with 7 neurons after so many trials to avoid overfitting of the network. One output neuron was used denoting 0 for normal and 1 for low bone mass. The network was trained until generalization stopped improving. This produced 96.7% accuracy in classification of training samples. There was a considerable decrease in performance of the network on the testing samples with only 73.3% accuracy. But compared to other trial experiments, this network gave the minimal difference between testing and training accuracies. The confusion matrices and the receiver operating curve plots obtained in the training and testing phases are shown here. From this, it can be suggested that this method can be used as a screening tool for osteoporosis. A further analysis with the standardized method may prove to be very effective.